Hello everyone. In this video, we will discuss theory of firms costs. We will compare accounting and economic costs. We discuss what are the opportunity costs, sunk costs, fixed costs, and variable costs. Accounting costs. Financial accountants consider accounting cost as the sum of actual expenses and depreciation charges for capital equipment. In fact, the accountants consider only the explicit costs involved in the process. Economic costs, on the other hand, include cost to a firm of using economic resources in production. So first we need to learn the concept of opportunity cost. Opportunity cost is cost associated with opportunity sacrificed when a firm's resources are not utilized to their best alternative use. Consider an example where a firm owns a building and thus doesn't pay rent on it. This is an implicit cost. Accountants doesn't consider the rent foregone on the building. That is, they do not incorporate this implicit cost, but the economists do consider the implicit costs. Hence, the opportunity cost of utilizing the office space is the rent foregone. So if we compare the economic cost and the accounting cost, we will find that the economic cost is sum of the explicit and implicit costs. On the other hand, the accounting costs involve only the explicit costs. Therefore, we can say that the opportunity cost, according to economists, is the sum of implicit and explicit costs, and therefore both economic cost and the opportunity costs are actually the same thing. Sunk costs are the costs that cannot be recovered. Suppose that before COVID-19 you registered your company with Australian Taxation Office to start a business. However, the COVID-19 shock affected the economy, and because of the uncertain situation, you could not do your business forever. But you already paid the registration fee for it, which cannot be recovered. Hence, it represents the sunk cost. Now we move towards the concept of total, fixed, and variable costs. Fixed cost doesn't vary with the level of output. We can imagine those fixed costs independent of the level of income. For example, we can say fixed cost is equal to some level C0. So if we draw the fixed cost curve with reference to quantity on the horizontal axis and the fixed cost on the vertical axis, we will observe a horizontal line as our fixed cost. To give an example for fixed cost, suppose you purchase a building for your factory. Whether you produce anything or not, this cost that you already paid to purchase the factory would not change. Likewise, without starting the production, you still have a security guard taking care of the property, and you are paying wages to him. Therefore, the wages paid to that worker without producing any output is also considered as the fixed cost. For any firm, the only way to avoid fixed costs is by shutting down. Thus, the fixed cost is independent of output level. Now we move to variable costs. Variable costs are the costs that vary with the level of output. If you want to increase the output, you have to input more labor, more capital, more raw materials, etc. And therefore, your variable costs will increase. Thus, variable costs are a function of the output level. Thus, we can present total variable cost as a function of quantity. For illustration purposes, suppose that our total variable cost function is given by output Q minus some parameter B times quantity squared plus some other parameter C times the output Q. And the output is positive or 0. Given the values of parameters B and C, if we want to plot our total variable cost curve against quantity, so when output is 0, quantity or quantity is 0, the total variable cost is also 0. Based on the parameters b and c, we will observe that we have a total cost curve which takes cubic shape. Now the total fixed cost, denoted by TFC, is K, and total variable cost is some function of quantity. Therefore, if we take the total cost as function of quantity, it would be the sum of total fixed cost and the total variable cost. Let us derive the total cost, average fixed cost, and marginal cost curves. First, we draw the total fixed cost curve, which is independent of the output level and hence is a horizontal line. As we learned, total variable cost is cubic and is 0 when output is 0 and increases as the output increases. If we add this total variable cost with fixed cost, we will get the total cost curve, which shifts up by the amount of fixed cost C0. Now we want to derive the average variable cost curve. For this, we have to consider the total variable cost. Let us draw a tangent line from origin to this total variable cost curve. The point of tangency occurs at some output level, and corresponding to that we have a fixed cost C0, but the variable cost is 200 and the quantity produced at this is 20. Now we observe that the tangent point is basically representing the rise over run relationship at this point, which means that we have an average function. So we describe that average, which is total 200 divided by quantity 20. So our variable cost 200 over quantity 20 will give us average variable cost, that is equal to 10. So we get a point 10 here. Then we have to draw the average variable cost curve. We see that the cost is falling for any output level which is less than 20, and then it reaches to its minimum at 20 and it starts increasing after 20. Think about the marginal cost function. We have to draw the tangent lines to this average cost. We have to draw the tangents to this total cost curve. So arbitrarily drawing, we get this curve as the marginal cost curve, which represents slope of the total cost curve. Next, we have to draw the average cost curve, which is the average of this total cost. So if we divide at every level of output the total cost, then we will get the average total cost. We observe that the marginal cost function passes through the minimum of the average variable cost and the average total cost functions. Thinking about the fixed cost and the average fixed cost, because fixed cost does not change with the level of output, as we produce more and more, our average fixed cost will decrease. Therefore, we get a curve which represents a hyperbola. We get our average fixed cost. Measure quantity on the horizontal axis and costs on the vertical axis. We observe that there is a relationship between the total cost and the average cost curves. If we divide fixed cost with quantity, we get the average fixed cost curve. Because fixed cost is constant and independent of the quantity, as we produce more and more of output, the fixed cost per unit will decline. So average fixed cost declines as we produce more and more of output. On the other hand, based on this cubic function, what we observe is that the average cost and the average total cost initially decline, then they reach at their minimum, and after that they start increasing. One of the key relationships between the marginal and the average functions is marginal function always passes through the optimum of the average functions. If it is a U-shaped curve, then the marginal function will pass through the minimum. And if it is an inverted U-shaped curve, just like the average product of labor, then the marginal product of labor, the marginal function, passes through the maximum of the average function in case of the inverted U-shaped curves. So the key relationship here is that the marginal cost curve always passes through the minimum of the average cost curves. This completes my explanation on the cost curves. Let us use some specific function and draw the curves. As an example, consider the total cost function TC, which is equal to fixed cost plus the total variable cost. Suppose the fixed cost is denoted by C0 and we hire L units of workers and pay them W wages, so the total cost or wage bill would be W times L. Also, suppose the production technology the firm uses is such that quantity depends on the number of units of labor hired, and it is equal to 2 times L raised to the power 1 by 3. Because L has power 1 by 3, therefore remember we have a concave production function. We take units of labor here and output here, and this is our function of labor. We are interested in finding different cost curves. Suppose C0 is given as 100 and per unit wages equal to say $3. Then we can write our total cost function as 100 plus 3 times L. From equation 2, we can invert the function such that Q over 2 equals to L raised to the power 1 by 3, and then we take power 3 on both sides so that it becomes L equals to 1 by 8 times QQ. We call that equation 3. Now we substitute equation 3 into equation 1a, and that gives us total cost equals to 100 plus 3 by 8 times QQ. This is our total cost as function of quantity. We have to identify the fixed cost and the variable cost. So we can see the total fixed cost is equal to 100 and the total variable cost is equal to 3 by 8 times Q cubed. If I want to compute the average fixed cost, I have to divide total fixed cost with quantity Q, which makes it 100 upon Q. And average variable cost would be total variable cost divided by quantity. So this makes my average variable cost function as 3 by 8 Q to the power 2. When I divide Q cube with Q, one power would be subtracted from 3 and I'll end up with 3 by 8 Q squared. Now total cost is equal to total fixed cost plus total variable cost, and if I divide this by quantity, I get average total cost equals to average fixed cost plus average variable cost. That means we have 100 upon Q plus 3 upon 8 Q squared as our average total cost. Now we compute marginal cost. Marginal cost represents rate of change in total cost with respect to output. That is, how much the total cost changes when there is an additional production of output. So we have to differentiate total cost function with respect to quantity, and that makes it 100 plus 3 by 8 Q cube. We take derivative of this. Remember, derivative of a constant with respect to variable is 0, and if we are applying derivative on Q to the power 3, that would be 3 times Q to the power 3 minus 1 equals to 3 Q squared based on the power rule. Therefore, marginal cost would become 9 upon 8 Q squared. We call that equation B. Call this equation B. Now we are ready to sketch the cost curves in Excel. After we substitute values into our function, we first get the production function Q, and we see that the production function here is a concave function. Output increases with the units of labor, but as we hire more and more of workers, there is there are diminishing returns to labor. Output increases at a decreasing rate, which is evident from the shape of the production function. Secondly, we observe that when we are increasing labor, although output is increasing, but what is happening is our cost is also increasing. So cost is increasing with higher workers. Thus, we have increasing costs here. Here comes in one important concept. We have diminishing marginal productivities of labor. That means as output is increasing with the labor, it increases at a decreasing rate. Hence, we have a decreasing returns to scale firm. Means that we have increasing costs. Thus, the relationship between a decreasing returns to scale firm is increasing costs. Next, we draw the cost curves. First of all, we draw the average fixed cost curve. We divide the total fixed cost of 100 with every level of quantity, and that gives us the average fixed cost function. Next, we divide our total variable cost with quantity, and that will give us average variable cost. The next step is to draw the average total cost curve. We see that we get a U-shaped curve. We are basically adding the average fixed cost to this average variable cost. So think about this level here. When we add this value here, we are basically adding average variable cost to our average fixed cost, and that gives us the average total cost. Finally, we have to draw the marginal cost curve. We see that the marginal cost is originating from 0 and it intersects the short-run average cost curve at its minimum, which is one of the relationships we have already established. From this example, we have learned that when a firm faces decreasing returns to scale technology, then it would have increasing costs. This is one of the important results we will use later. Based on the same argument, we can find that a firm that faces increasing returns to scale would have decreasing costs, and a firm that faces constant returns to scale will have constant costs. So this completes my analysis of firms' costs in the short run. Thank you very much.